right. How's everybody doing today? Cool? Having a good show so far? So thank you for coming to listen to our talk today. My name is Dylan Silva. I'm the Ansible Engine Product Manager at Red Hat. I'm joined by Alex Steven. He's with Google. Alex, give yourself a...
Hey, I'm Alex Steven. I'm a software engineer over at Google. I'm at Ramble Raptor all over the internet, and my job is to build in fantastic Google Cloud support into Ansible. So I'm excited to show you all what we have.
Yeah. So we're gonna talk about that today, obviously. Alex is pretty much gonna drive this. I'm just here for help. Any questions? I'm gonna talk a little bit about Ansible. Quick question here: how many of you folks use Ansible today? Because I assume. Okay, cool.
Pretty much everybody.
I apologize. Right? So I'll apologize ahead of time. I got just a couple of slides to talk about Ansible. So it's for those people who don't know, obviously. And that's what Alex was going to do.
So how many of you are using Google Cloud? Small handful. Okay. Better question. How many of you have heard of Google Cloud? Awesome. Okay.
Sweet.
That was a lot more than I expected, so that's exciting. So I've got a couple slides kind of walking you through the whole Google Cloud pitch. But yeah, I think, bear with me on that.
So how about kicking us off?
Yeah, sounds good. So yeah, quick little overview of what we're going to be talking about. I'm going to do a little overview of Google Cloud. Dylan's going to do a little overview of Ansible. And then I'm going to do a little demo where I take a on-premise application that I've deployed with Ansible, and we're going to move it over to Google Cloud in a really cloud-native way. So first of all, let's talk what is Google Cloud. Show of hands, pretty much everybody knows. Just for the few of you that don't, Google Cloud is Google's public cloud offering, and our goal is pretty simple to explain. We want you to run your applications, run your workflows on the exact same global infrastructure that powers Google. And I think there's a whole bunch of different reasons why Google Cloud is really an amazing set of products. One of the ones that I think is the coolest is our global network. Google has the largest private network in the world. We run it all on our own private fiber. We have more than 100 peering locations, edge locations all over the place. We can scale up to 1 million queries a second with absolutely no warning whatsoever. If you need global load balancing, we can do it all over a single IP. We work with a scale that is absolutely unprecedented across the entire industry. And going along with that, Google Cloud offers just about everything. I've actually got I've got 2 slides worth of products, and this isn't even everything. So we offer the standard, compute VMs, we offer DNS, we offer SQL databases, we offer cloud storage buckets, and then we get into some of the crazier stuff. We offer machine learning, we offer natural language processing and video. The idea being, again, it's the same stuff that Google uses. We want you to be able to leverage all of the work that Google's been doing in machine learning, in building and running data centers and Kubernetes clusters, and use that to kind of drive all of your applications forward as fast as you can. Google Cloud is also a really great financial decision. So to start out with, we do billing on a per-second basis. We have custom machine types, the idea being that if you only need machines that have 2 cores and 3 gigabytes of RAM, create a machine that has 2 cores and 3 gigabytes of RAM. If you need a machine that has 35 cores and 17 gigs of RAM, create a machine with just that. We also have sustained use discounts, the idea being that the longer you keep a virtual machine or the longer that you are using something from Google Cloud, the cheaper it's going to get over time. And we'll figure out all of the math for you. If you're using 2 virtual machines for half a month apiece, we'll say, well, hey, that's the same as using 1 virtual machine for 1 month. And it turns out that using 1 virtual machine for 1 month is quite a bit cheaper than using 2 for half a month apiece. So we'll go ahead and do all the math for you and give you the best deal. And then likewise, what I think is one of the coolest features is we actually do automatic right-sizing recommendations. So if you are using a machine that's vastly overpowered for the workloads you've been using, we'll actually proactively come to you and say, we notice you haven't been using this machine to your full potential. Why don't you downgrade it to a machine that only has 3 cores instead of 6, and you're going to save X dollars over the month. So kind of the TLDR of all of this financial stuff is we only want you to pay for what you're going to be using. We don't want you to be paying for anything you're not. We want you to build apps and use only the exact amount of infrastructure that you're going to need. So now I think Dylan's going to talk a little bit about Ansible.
Yeah, sure. So first off, I want to take a high-level view and talk about the what is Ansible. So we kind of classify it into 3 things. One, it's the platform, it's the engine itself, the automation language. It's also the open source community that drives the whole Ansible automation family. Ansible engine itself is the supported product that we provide at Red Hat for the project. It's built from the project itself. And then Ansible Tower is our offering that sits on top of Ansible engine as a REST API layer and a central management location for all that is Ansible. So why would a person use Ansible? Obviously, all of you in here, pretty much all of you in here, use Ansible today in some form or fashion. But for the people who don't know, for those of you on the video, we like to say 3 things about it. A, it's simple. Why is it simple? Well, hey, writing in YAML in a playbook, it's very straightforward. You just write a simple task heading, basically a note of what is this task doing. And then the syntax itself is human readable. You can say, just a very basic name value pair for your playbook syntax. It's also powerful. You can basically do everything with it. Obviously, it's a configuration management system. Everybody knows that. But what some people don't know, it also acts as an application deployment system. You can use it to attach systems to monitoring. You can also tell load balancers to change where your traffic is going to and from. You can also maintain your network stack. Basically, the sky's the limit of what you can maintain with Ansible itself. So therefore, it's very powerful. And then finally, the cool thing, everybody knows this, it's all done agentless. SSH for the Linux systems, WinRM for the Windows, and then everything else is over REST API or just basic command line structures through the application itself. And then finally, how does Ansible work? We're going deep into this now. So once again, playbooks written in YAML. Tasks, by default, are executed sequentially from top to bottom. There are many other methods that you can do that. We call those strategies. And then those invoke Ansible modules. What is a module? That's the fun stuff. That's the tools in the toolkit. That's what does most of the work. Those plugins that they're either Python-based, PowerShell-based. Really, they can be any language that interact with Ansible to do the work on behalf of the user. And that's what really extends the simplicity to the entire stack. That's what allows you to write those very simple playbooks. So once again, I mentioned plugins. There are other types of plugins. You got a lookup plugin, you got a filter plugin, you got a strategy plugin. The list goes on of the different types of plugins. Modules are essentially plugins. They're extensions of action plugins at some form or fashion. But that's the way you adapt your use cases to the full Ansible stack. Inventory, we have inventory plugins now. That's yet another type. Originally, we had inventories were either in INI format or they were a dynamic inventory script in Python or some other language. But now, taking it to the plugin level, you can extend even further with your inventories through a dynamic inventory plugin. And here's an example of an inventory. You can also extend those dynamic inventory plugins to other CMDBs, like a cloud. So GCP, for instance, you can interact with the API to pull out the instance data for all of the instances in GCP or for any other various cloud, like OpenStack, Rev, VMware. The list goes on and on of what you can interact with. Any custom CMDB like ServiceNow, so on and so forth. So I'm going to kick it back over to Alex. We're going to talk a little bit about why Ansible plus GCP, and we're going to kind of tote our own horns of the collaboration that we have between our teams.
Cool. So hopefully I've kind of pitched you all on this idea of the cloud is awesome. Google Cloud is great. Take all of your workflows, move them all to the cloud. It's cheaper. You get more scalability. The next question is, what kind of tooling are you going to be using to do this? There are 1.5 million different ways to spin up cloud resources, something as simple as a bash script all the way to using something like Ansible. So I think it's important to kind of figure out why Ansible is a great choice for creating Google Cloud resources. So first of all, because this is Ansible, because playbooks are YAML files, you're going to be able to version control your infrastructure. Infrastructure can get complicated. You're going to be, depending on the size of your operation, you're going to be needing more stuff or less stuff, and these needs are going to evolve over time. Inventories are great at showing you what you currently have. They're not great at showing you what you might need in the future or what you had in the past. And so that's what version control is going to allow you to do. It's going to allow you to see how your playbooks have changed over time. And they're going to allow you to add processes such as code reviews and the like to make sure that your infrastructure is going to be in the state that you want it to be. The next is, because this is Ansible, and everybody in this room pretty much has used Ansible, you're going to be able to create these entire pipelines using a tool that you already know. You're going to be able to create Google Cloud virtual machines and then deploy your applications onto those virtual machines, or create databases, or create load balancers, or DNS records, whatever it is that you need to power your application. You're going to be able to create that using the exact same tool that you already know how to use. And then lastly, just to build onto that, you get to use all of the additional tooling that you've built up around Ansible in order to now build your cloud infrastructure. You're going to be able to use Ansible Tower, which I'm actually going to be showing you later on in the demo, and everything else that you've built up with Ansible in order to now create these end-to-end pipelines of infrastructure all the way to code. So as part of the work that we've been doing together between Google and Ansible, we've been building a whole new set of auto-generated modules. The idea behind these modules is that they're supposed to be a consistent and comprehensive way to create pretty much everything that you would ever want to create in the Google Cloud platform in a way that's really, really easy.
Yeah, I'd like to add to that really quick. You know, one thing that, from the project's perspective, from our development perspective, is we really prefer our partners and the individuals that know their product best to write the content for that product, because we're only a small team of engineers that are working on the platform itself to enable these content developers to do what they do best, is that's providing that content to you. And the cool thing about this automated approach is, hey, in the good nature of automation, why not take this to the next level? And we worked very closely with Google on making sure that this was as tight as it could be from a module perspective.
Yeah, and likewise, yeah. So one of the great things about creating auto-generated modules is that all of these modules are incredibly consistent between one another. When you know, obviously, as I was showing you earlier, Google Cloud has a lot of different products. You can create a lot of different things. And the big goal is, if we hand wrote these modules, all of the modules would eventually look and feel differently. It's just, when you have a bunch of developers working on a bunch of things, it's just bound to happen. Because of the approach we're taking, all of these modules look and act the same. If you use one module, so for instance, I've shown a little block of code to the right for creating a Google Cloud instance, virtual machine. Once you learn how to create one thing and learn kind of the authentication and some of the other things about it, pretty much authentication, you're able to go forward and build whatever you want. You already know all of the primitives and all the ideas behind the modules. And then likewise, all of these look very similar to Google Cloud's API, as well as other cloud tools that are being used to spin up resources. If you've ever spun up a resource on Google Cloud using a different tool, this is going to be an incredibly quick and easy transition for you because you already know everything you have to know. You already know everything from the Google Cloud side. Now you just have to bring in your Ansible knowledge. And as Dylan was saying earlier, we've been working really closely with Ansible because we really want to get these modules right. We really want to make sure that the Ansible community knows how to use them because they've been conforming to best practices. We want to make sure that these modules are going to be able to stand the test of time. There's not going to be large API changes, large deprecations. We want to make sure that we get this right the first time around.
And we just want to get the content out to you quicker.
Yes.
As well.
So building on that, because these are auto-generated, we can crank out new modules really, really quickly. Right now in Devel, we already have 14 different Google Cloud modules spread across 5 different product types. You can build up compute resources, DNS resources, cloud storage resources, some Google Kubernetes engine resources, as well as do some pub/sub work. And we're able to gain great velocity. 2.6 code freeze comes up in a couple weeks. By then, we're going to double the number of modules that we're going to have, going from 14 to at least 28. I'm hoping for more in the 30s range, but we'll see. I'm going to make it happen. Lastly, Google is really committed to making this work. We've been adding GCP-related modules since Ansible 1.4. We've been working with the community. Ansible 1.4, that's 2013. That's 5 years ago. It's been a long relationship that we've had with Ansible.
You can thank that guy right in the back there, Hayden. He started a lot of it. Yep.
And now that we've embarrassed my boss. And yeah, we've had full-time engineers working on this. This is what I do 40-plus hours a week. This is what I eat, dream, and live about. So now, I think, better than kind of going on and on about these modules, I'd love to show you something. So I've got a demo that uses all of the new modules that we've been building. I'm going to take a on-premise application and move it over to the cloud in a pretty cloud-native way, and then show you how Google Cloud lets you scale up your application really, really quickly. So to start out with, I've got this on-premise application. And I'm pretty sure this is going to look very similar to what everybody in this room is doing right now, which is I've got a machine that Ansible is installing on a little, in this case, it's a Python web app, which is really just meant to be kind of a stand-in for, a big monolithic app. And so Ansible is installing in all of my dependencies. It's installing in the application and the configuration to make it go to a database. So let me show that to you right now. So I've got a Ansible Tower going. And if we look at my inventory, I've got an on-prem inventory. And so you can see this is my one on-premise box. And I think a couple days ago, or before this talk, I went ahead, kicked it off, and I'm installing an application on-prem. So now if I go off to my application, you can see I've got my little application that serves up pictures of dogs wearing red hats. So yeah, this is all deployed using Ansible, talking to a database, configuration, all of that. There's also, and this is terrible security practice, but you'll understand why I did this later, I've got a little endpoint that just serves up the host name of the machine that this application is currently running on. So this machine, I just named it on-prem to make it really obvious that this machine is in fact on-premise. So now, I'm going to kind of jump back to my slides. Let's talk. Did that work? Cool, that worked. let's kind of talk about the notion of cloud native. I think it's one of those buzzwords, and at least when I personally hear it, I kind of get images of Kubernetes clusters and microservices and globally load balanced NoSQL key value databases. And the first thing I think about is, oh man, to really take advantage of the cloud, I just got to take my application, rip it apart, and start from step one. And that, just raise of hands, is that a realistic option for any of you to rewrite your entire application, use the cloud? Okay, so let the record show that not a single hand went up. So I think a better way of looking at what is cloud native is to think about this idea of immutable infrastructure. So in the on-premise world, your machines last forever. You keep a machine going from now until the end of time. And over time, that machine starts to diverge a little bit from where you want it to be. You know, this is how snowflakes happen. Something bad happened, and you have to quickly SSH into the box and make a little change that you didn't want to. And so over time, as your, if your machine ever fails, you can't just start fresh. You have to go in and manually make alterations and manually figure out what's going to happen. And in a cloud native world, this isn't what we want to build. We want to build machines that can be spun up quickly, destroyed quickly. If something happens, I don't want to figure out how to fix it. I just want to destroy that machine and spin up a new one. It's the cloud. There's a million machines out there. I can get them. Google Cloud, it's really cool. You can spin up a VM in, I think, about 3 or 4 seconds. So there's no use in trying to SSH into my machine and figure out what's going on. Just kill it and bring up a new one. So how can we, what's a good practice for trying to take our application and move it towards this world of immutable infrastructure? And I think one of the great ways to do this is by creating images. So right now, my machine, my Ansible playbook, installs my dependencies, it installs my applications, installs my databases, my Nginx, my Python, everything all at the same time. Instead, what I want to do is I want to create an image that has just my dependencies on it. So it's a one-time cost, and I have this image that has Python, it has Nginx. It doesn't have my application, just all of the things that my application requires in order to run. Now I can take this image and I can pass it around throughout my organization. So when I'm running machines in prod, I create my machine in prod with my image, and then I just use Ansible to install my application, because my application changes. Whereas my image, Python, Nginx, these things will rarely, if ever, change. But I can also now take this image and I can spread it to my staging environments. So now I can ensure that my staging environments are matching my production environments, because they're using the same image. And by using the same image, they're therefore using all the same dependencies. I can start to build CI/CD pipelines, where every step of the pipeline uses the exact same infrastructure because it's using the exact same image. If it works in my CI/CD pipeline, it'll work on staging, it'll work on production. I can even take this all the way back to my development environments, where I can spin up a virtual machine that has this image on it, and so I can do my development on all of the exact same dependencies that I'm doing the rest of my workflow on. So now throughout the entire development pipeline, everything I can ensure is using my same set of dependencies. So how can we build these images? There's 1.5 million ways of doing this. But in the spirit of let's use Ansible, let's use Google Cloud, let's use the knowledge we already have, and let's use Ansible and Google Cloud to do this. Let's spin up a Google Cloud VM. Let's use Ansible to install my dependencies onto this machine. And then let's tell Google Cloud, build me an image from this machine that just has my dependencies. So that is a one-time task that I have to do. And now I've got an image that I can use throughout my development pipeline. So ultimately, to start out with, I'm going to build something that looks like this. And this is pretty much the exact same thing I had on-premise, but now it's on the cloud. Instead of having an on-premise machine, I'm going to replace that with a Google Cloud VM. That VM is going to be based on this image that I create that has just my operating system and my dependencies. And then I'm going to use Ansible to inject in the application that I've built. Now, I could also, go all out and actually migrate my database over to Google Cloud SQL and kind of get all of the reliability and the speed that that does. That's a little complicated for this demo, so I'm not entirely going to do that just yet. So I'm going to go over back to my Ansible Tower and pull up my different jobs. And so I actually, ahead of time, already built my image. Building an image isn't a terribly long process, but it's long enough that it would require me to riff in the middle of my talk, which I am absolutely terrible at. So I've already got an image set up that I built with Ansible and Google Cloud that contains Python, it contains Nginx, it contains all the dependencies that I need for my little Python app. So I'm going to go ahead and I'm actually going to stand up an instance using this image. So we're going to go ahead, kick that off.
So while that's running, I want to ask all you folks a question. In Ansible, just shout it out. What is something that is pretty close to being immutable that you're able to write? Anyone? Just shout it out there. I heard something. So it uses playbooks. I think I heard it. Say it again. Yep, a role. So one thing that we always like to say is a role is one of the first immutable types that have been out there. That is one thing that you can use in multiple environments to drive your playbooks in a very cohesive manner and keep it the same from environment to environment. In what way? Mm-hmm. 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 Yeah, it's a lot more in depth now, for sure. Yeah. We even have a concept of workflows now within Tower, so you can take a bunch of different projects and roles within those projects and chain them together and do some really crazy stuff with it.
Yeah, speaking of workflows, I actually purposefully did not use workflows for this demo because workflows enable a lot of magic. I actually wanted to step through the various steps of this process because otherwise, like, Ansible will automate all of this away for you. It will be a zero-click process. So now I've stood up an instance, took 45 seconds, and most of that was time spent gathering facts. So now let's verify this. So the cool thing about Google Cloud, and really about the cloud in general, is that your inventory is very dynamic. And Ansible Tower recognizes this, or Ansible as a whole recognizes this. And so Google Cloud has a great dynamic inventory script. So I'm going to go ahead. We can actually look, right now I don't have any cloud hosts, but let's kick off my dynamic inventory. And it's going to take just a second here. So now if I go to my list of hosts, there is my production instance. And you can see it's already tagged with a bunch of different tags, including the zone it's in, and more importantly, it's tagged with that image that I created. So I create a lazy name, I just called it test image. But now I have a way of going through and doing plays on just machines that have my image on it. So just machines that already have my dependencies all set up. So we can actually pop back over to jobs. And let's go ahead, and so I've got this machine now. It's got Nginx and Python, so it has the dependencies for my application, but it doesn't actually have my application on it. So now we can go ahead and install my application onto this machine that I've created. And so because of the magic of Ansible inventories, Ansible is able to go through and say, okay, well, I'm looking for all of the cloud machines that already have my image on it, and it's going to go ahead and, it identifies the machine properly, and then it installs on just my application. So when I built my playbook originally, my on-premise playbook was this long playbook that had, install Nginx, install Python, install my application, installed everything. In a cloud world, I split that playbook up into two playbooks. One of my playbooks installed just Nginx, just Python, just my dependencies, and I used that in order to create my image. And then the second half of my playbook is now this playbook that's just installing my application. And so that's why the install process goes super quickly, because I'm not really installing anything. I'm cloning a Git repo and then kicking off a service to start up my web server. So now, if we go, I've actually got this set up to a different DNS name, because DNS is not your friend in a live demo. We can see another dog in a red hat. And so if we actually refresh this page a couple times, we'll eventually get the first dog, and that's because this is hooked up to the exact same database. I am using the exact same configuration I was using on-premise. I'm hooked up to the exact same external services. But if I look at my host name endpoint, I'm now using a cloud-based host because, migrated to the cloud. So let me flip back to my slides. Doing this, oh, come on, load, there we go. This is a pretty basic example because, this is exactly what I had on premise. Why should I move to the cloud, other than it's probably cheaper, if I'm just going to do the exact same things I'm doing on premise? The great thing about the cloud is I can scale incredibly easily. So in order to show that, let's scale from one machine. Let's scale to 4. I'm picking 4 as my arbitrary number, mostly because I'm still on the trial version of Ansible Tower. So let's create 4 different machines. Let's put them behind a load balancer that's going to intelligently route traffic to whichever instance is experiencing the least traffic. And let's also have this be a managed instance group, so that if something strange happens and one of my boxes crashes, Google Cloud will automatically just delete the box, create a new box, and automatically set everything up for me. So let's go ahead, let's give that a shot. So I'm going to go back to my Ansible Tower. And this time, I'm going to create a load balancer, which is going to use the same Google Cloud modules that we used in order to create these same Google Cloud modules that we used in order to create one instance, we're now going to use to create a grouping of 4 instances. So now if we pop back over to Cloud Inventory, right now we have one host. If we do a sync again, we now have a whole series of hosts. We've now got the 4 different instances that I've created. And in my script, I said how I wanted all of these to be prefixed, so we can actually see that all of these belong to the load balanced instance group. These are all part of one group. They're all going to share one load balancer. And each one of these instances was creating using that same image. So all of these are completely immutable. They're all sharing the same dependencies, operating system, everything I need. But they don't yet have my application. So let's go ahead and let's add on my application. So I can use the same playbook that I've been using for installing my application, except now, thanks to dynamic inventory, Ansible, let me kick that off. So now, thanks to dynamic inventory, Ansible is going to go through and say, well, Google Cloud has told me that you don't want to install this application on one machine anymore. You actually want to install it on 5 machines. The one machine I had from the first demo, where I just stood up a one machine demo, and then now this new setup where I have 4 instances behind a load balancer. So you can see, Ansible is installing my application on each of the 4 machines. And just a second, that will be done. And it does, so there we go. So now let's go ahead and go to my last one, and we see the dog, again, using the exact same configuration, hooked up to the exact same external database. And if I go to my host name, you'll see it's showing me that I'm connecting directly, in this case through a load balancer, to one of those 4 instances that I created from earlier. And if I refresh the page a couple times, you'll notice that that host name doesn't change. And that's because Google Cloud's load balancer is intelligent enough to know that I presumably am the only person connecting to this application right now. And me refreshing the page, I'm not driving enough traffic to warrant having to go through to a bunch of different instances. One instance can handle what little traffic I'm giving just fine. So I've actually got a little curl script that's just going to try to, can everybody see that all right? Cool. So I've got a little bash script that's just going to throw as much traffic at this load balancer as it can. And we're going to see, if I go ahead and run that, we're going to see how we're starting to go into different instances. And the Google Cloud Load Balancer is intelligently throwing traffic at whichever machine it thinks it needs to be throwing traffic to. Present. So that's really Google Cloud. That is Google Cloud in a way, that is using Google Cloud to take your on-premise application, move it to the cloud, and then scale it up to 4 machines, 10 machines, 20 machines, whatever scale you're going to need, all using the Ansible toolkit. So with that in mind, now it's everybody else's turn. We've got a whole bunch of Ansible modules right now on the develop branch. By the time that 2.6 comes out, we're going to have even more modules. So please check them out, as well as docs.ansible.com to see all of our documentation. If you're at all curious about Google Cloud, feel free to go to cloud.google.com to get a whole bunch of more information, as well as we've got a $300 free trial to give you money to play around with. So that is true, but we also have a always free tier. So we give you a machine and a database, some storage for free from now until the end of time itself. And then also, if you've got any more questions, I'll be sticking around here. I'll also be at the booth. So feel free to ask me any and all questions you have. So yeah, thanks a lot, everybody.
So one takeaway I'd like to add is definitely take a look at this great content that we developed together. There's a lot of it. Our feeling is it will help you become more cloud native than the norm out there with the Google Cloud Platform. Really, the goal, the nirvana, is not to do the instance approach. I would say it's going directly into those services that host your applications and your databases and so on and so forth. That is the way to go towards. The cool thing is you can easily get to that using those modules, those roles. A lot of this demo is a very boilerplate demo. We have a very similar one in Ansible examples that we provide as well. So definitely give it a try. Try it out on Google Cloud Platform with that free $300 that you're getting from them and see what it's like. The platform's awesome. I'm a huge fan of GCP myself. I used it at a prior role before I worked at Ansible, so I definitely can suggest it. And you know, we put a lot of our thoughts and feelings behind these modules. along with our partners at Google. So definitely give it a try.